You've heard it a million times, right? The human brain is just like a computer. It's a really powerful way to think about it, but how true is it? Well, today, we're going to put that idea to the test. We're putting these two incredible systems head-to-head to see what really separates them. Let's get into it.
So here's the big question, the one scientists and thinkers have been wrestling with for decades. Is that amazing organ between your ears basically the same thing as the machine on your desk, just, a bit squishier? Is it all just hardware? One made of flesh and the other of silicon?
All right, first up in the ring, we've got the reigning champion of cognition, a masterpiece built by millions of years of evolution, the human brain.
So what is it, really? At its most basic, the brain is our biological command center. But it's so much more than that. It's not just a processor. It's this incredibly complex, living system that learns, adapts, and even creates. It's where our memories, our experiences, our very consciousness comes from.
And to give you an idea of the sheer scale we're talking about, your brain has about 100 billion neurons. That's more than the number of stars in the Milky Way galaxy. And get this, each one of those neurons can connect to thousands of others, creating a network that is just mind-bogglingly complex.
Now here's where it gets really cool, and this is a huge difference. The brain doesn't have a fixed circuit board. It's constantly rewiring itself based on what you do and what you learn. Seriously, every time you learn a new fact or a new skill, you are physically changing the structure of your own brain. It's alive, it's dynamic, it's not static at all. And in the other corner, we have the challenger, a marvel of human engineering and logic, the computer.
A computer, unlike the brain, doesn't just do things on its own. It's an unbelievably powerful tool, for sure, but it does exactly what we tell it to. It follows instructions with a speed and a precision that's just breathtaking. But those instructions have to come from somewhere, from a person, from a program,
And its building blocks are totally different. We're not talking about living cells here. We're talking about transistors, which are like tiny little on-off switches, and logic gates, all connected in a very specific, pre-designed way to make up its circuits. And that right there is a fundamental difference. A computer's physical layout, its internal structure, is set in stone from the moment it's built. It is designed to follow a very strict set of rules. It's programming. It can't just decide to reorganize its own circuits because you taught it how to play chess.
Okay, introductions are over. We've met our two contenders. Now, let's put them side by side and see how they really stack up when you compare them directly. Let's kick things off with power consumption. Your brain, while it's doing all this incredible stuff, thinking, feeling, keeping you alive, runs on about 12 watts of power. That's less than a dim light bulb. Meanwhile, a supercomputer doing really complex calculations can chew through gigawatts, enough electricity to power a small town. The difference in efficiency is it's staggering. I mean, when you look at it like this, it's not even a fair fight. The brain's energy efficiency is something engineers can only dream of. It is a true masterclass in doing more with less, perfected by nature over millions of years.
Okay, what about memory? A computer's storage is finite, right? You've got a certain number of terabytes, and when you fill it up, that's it. You have to literally buy more hardware. But the brain? Its storage capacity is considered to be practically infinite. Its memory grows organically, by making new connections or strengthening old ones. You never get a storage full error message when you're trying to make a new memory.
And the way that information gets stored is completely different too. Computers use a clean, precise binary code. Everything is a 1 or a 0. The brain, on the other hand, uses this much, messier system of electrical signals and chemical reactions. It's analog and fuzzy, not digital and precise.
So what about pure processing power? This is where the computer has the edge, isn't it? Well, yes and no. A computer is an absolute speed demon for crunching numbers in a line, one after another. It can process billions of instructions a second. But the brain is the undisputed king of parallel processing. It does millions of things at the same time. It's processing what you see, what you hear, your balance, your thoughts, all at once. It's a different kind of horsepower entirely.
So after all that, what's the verdict? Is the brain just a fancy biological computer? Let's boil it all down to the most important takeaways. It really comes down to these three things. 1. The brain changes itself. It learns and adapts. A computer is fixed. 2. The brain's memory is seemingly endless and grows on its own. A computer is limited by its hardware. And 3. The brain is amazingly resilient. It can often work around damage. When a computer breaks, it just breaks. It needs a person to fix it. But maybe the biggest, most profound difference is this. At the end of the day, a computer just follows instructions. The human brain has genuine autonomy. It can look at a messy, ambiguous situation, weigh different options, and make a judgment call. That is a fundamentally different thing than just executing code.
Okay, so they're different. Who cares? Why does any of this actually matter in the real world? Well, understanding these differences isn't just some fun thought experiment. It's absolutely crucial as we try to build the next generation of artificial intelligence. It helps us understand what we're actually trying to create, and maybe, just as important, it gives us a much deeper appreciation for the incredible, super efficient, self-healing machine that we all carry around in our heads.
So I'll leave you with this to chew on. As our AI gets more and more powerful, are we really teaching it how to think the way a brain thinks? Or are we just getting better and better at building incredibly sophisticated calculators? The answer to that question is going to shape our future. Thanks for diving in with me today.